we are going to use the kinetic pressure of a gas to deduce the relationship between the mean kinetic energy and the absolute temperature. So here we know that the kinetic pressure of an ideal gas is given by a third times the number of atoms multiplied with the mass, then divided by the volume. Now since this gas was in a tube, we shall take L cubed as the volume, then times the mean square speed. So if L cubed is the volume, it means that the pressure is going to be given by a third Nm over the volume times the mean square speed. So we shall now get V on the left hand side, so that we get PV as a third times the number of molecules or number of atoms multiply with the mass multiply with the mean square speed. Okay, so now from here we know that for an ideal gas, PV is equal to nRT, where n is the number of moles, R is the molar gas constant, and it is the absolute temperature. So we are going to replace PV with nRT. So we shall have a third times Nm over, no, it is Nm times the mean square speed equal to nRT. Now we are going to consider for 1 mole of a gas, for 1 mole of a gas, from this statement or this expression, N will be equal to 1, then the number of atoms in 1 mole N will be equal to Na, Avogadro's number. So if we substitute these two in this expression, we shall get a third N times mass, but now the N we are going to use is the Na times mass times the mean square speed equal to RT. So now I'm going to multiply with 3 over 2 on both sides, because I want to create the expression for kinetic energy, which we know that it is a half m times speed squared. So from here, let us multiply with 3 over 2. Now from here we shall get this 3 cancel with that, so we shall get a half times m times the mean square speed equal to 3 over 2 times R, then over, I'm going to take this n the other side, then times T. But note that Kb, Boltzmann's constant, is given by R over Na. So, and this a half m times the mean square speed is the kinetic energy, mean kinetic energy. So from here we shall see that the mean kinetic energy is going to be equal to 3 over 2 times the constant K times the temperature. So that means that kinetic energy, mean kinetic energy, is directly proportional to the absolute temperature, because 3 over 2 times K is a constant, so we can just deduce that the mean kinetic energy is directly proportional to the absolute temperature. So that is the relationship between the kinetic energy and the absolute temperature.